May 2022 predicted paper question 4, surface area and volume of cuboids. Here we see we have a diagram showing a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. So I'd be tempted to think of that word surface area. I don't know about you, I think about painting it. I've got to paint all the sides. You might think of I've got to make it out of cardboard, or I've got to wrap it. How much wrapping paper do I need? The first thing I would do faced with this type of question is to think, what sides have I got to paint? I've got to paint, and I like to name them, you don't have to. I've got to paint a front, and I've got to paint the side at the back. I've got to paint the one on the right, and I've got to paint the side on the left. Then I've got to paint the side at the top, and I've got to paint the side at the base as well. So if I could work out all the areas of these, that would give me a good fighting chance at getting lots of marks on this 4 marker. The dimensions of the front, well, it's 6 by 8. Area of a rectangle, 6 times 8, 48. The one at the back, of course, is exactly the same, 6 by 8, 48. The dimensions of the right-hand side, 6 by 18. At that point, under pressure in the exam, I might do a formal long multiplication in the margin. 6 times 8 is 48. I need my placeholder because I'm not doing 1 times 6, I'm doing 10 times 6. 10 times 6 is 60. 108 is the area of that side, and the area of the side on the left will be the same as well, 108. The dimensions of the top face, 8 by 18. Again, under pressure in the exam, 18 times 8. 8 times 8, 64. 10 times 8, 80. The area of this side, 144. Base as well, 144. I now have to attempt to add up all of these 6 numbers in one go. Well, that probably won't happen in the exam for me. I'll probably get that one wrong. So instead, I tend to add the top 2, 96. Add the middle 2, 216. Add the bottom 2, 288. And then adding up 3 numbers is far less likely to go wrong than trying to add 6. 6 add 6 is 12, add 8 is 20. 9, 10, 18, 20, 2, 4, 6. And at this point I'd like to show off. Surface area, 600 centimetres, its area, so squared. So let's write that on there. We know the surface area of the cuboid is 600 centimetres squared. Thinking now about the cube, it says the surface area of the cube is the same, it's equal to the total surface area of this shape. That means there's 1, 2, 3, 4, 5, 6 sides of the cube, so I know one of the sides of the cube will be 600 centimetres squared divided by 6, so I know each side is 100 centimetres squared, coming from 600 divided by 6. Quite rapidly I can figure out that each side of the cube must be 10. 10 times 10 is 100. Let's put those measurements on the cube. And that's the total of that bit of information told done. We now read on. Janet says the volume of the cube. So a new question. Got to work out the volume of the cube. 10 times 10 times 10. Well, 1 times 1 times 1 is 1. We've got 1, 2, 3 zeros. 1,000. And a bit of showing off here. Centimetres volume cubed. We've worked out the volume of the cube to be 1,000 centimetres cubed, and now we can look at the volume of the cuboid. For this, we've got to do 18 times 8 times 6. Fortunately, I've already done 18 times 8, it was 144, so I may as well use that working. And I've got to do 144 times 6. If it's the same as 1,000, then Janet's correct. 4 times 6 is 24, 4 times 6 is still 24, it's not changed, plus the 2 is 26. 6 times 1 is 6, plus the 2 is 8, 864 centimetres cubed. Just to reread the question once more, it said, Janet said, the volume of the cube is equal to the volume of the cuboid. Is Janet correct? No. I would probably then write something along the lines of 1,000 centimetres cubed is not the same as 864 centimetres cubed.